How Tornadoes Form, the Science Behind Nature's Most Violent Storms. Welcome to this explainer. Today, we're literally tracking the life cycle of an absolute monster. We are going to go from deceptively clear skies to violent destruction to see exactly how these things are born. Just imagine you're standing outside on what seems like a completely ordinary afternoon. Then, dark clouds start to build overhead, the wind suddenly shifts direction, and the sky turns this eerie, super unsettling shade of green. And then, completely without warning, a massive rotating funnel drops from the clouds and starts tearing across the land at speeds faster than a race car.
It's a completely terrifying scenario, right? A tornado can literally level an entire neighborhood in just a matter of minutes. But how does something with that much sheer power actually form in the first place? And maybe the bigger question, what makes one storm out of thousands turn into a deadly tornado while the vast majority of other thunderstorms just, rain themselves out and fade away? Well, today we are tracking every single stage of tornado formation, breaking down the invisible physics of the atmosphere into totally clear, easy-to-follow steps. Okay, let's dive right in by looking at the recipe. There are 3 simple and usually harmless ingredients that absolutely must combine to kick off every tornado. First up, you need warm, moist air sitting right near the ground. Second, you need cool, dry air higher up in the atmosphere. And finally, you need strong wind shear, which basically just means winds that are changing both their speed and their direction as you go higher up. Now, sitting by themselves, isolated in the atmosphere, these ingredients are totally harmless. But when they come together in just the right way, they create one of Earth's most dangerous weather systems. And this invisible atmospheric collision is exactly why the central United States, which we famously call Tornado Alley, experiences so many of these violent events. It is literally the ultimate geographical collision zone for these specific air masses. Think about it. You have warm, moist air constantly pushing north from the Gulf of Mexico. At the exact same time, cold air is dropping down from Canada, and dry air is sweeping in from the Rocky Mountains. This unique geographical bowl essentially funnels these 3 distinct air masses directly into each other. It provides the absolute perfect atmospheric fuel for violent storms, more often than anywhere else on Earth. So, how does it start? Well, the whole process actually kicks off with the sun. As sunlight heats the Earth's surface, that warm, humid air near the ground gets lighter than the air around it and starts rising super fast. As it climbs higher and higher, the air cools down and the water vapor inside it condenses into tiny droplets. That's what forms those towering cumulonimbus clouds. And here's the cool part. That condensation actually releases extra heat into the storm, which makes the rising air pull upward even harder. Pretty soon, you've got a thunderstorm stretching over 50,000 feet into the atmosphere. I mean, that is higher than commercial jets fly. It's completely packed with heavy rain, lightning, hail, and massive updrafts. But importantly, there's still no tornado yet. To get that tornado, we have to talk about wind shear. This is absolutely crucial, because without different layers of atmospheric wind blowing at totally different speeds and directions, the storm simply can't rotate. Imagine you're standing on the ground, and the wind is blowing in your face from the southeast. But several thousand feet above your head, the wind completely shifts. Up there, it's blowing toward the southwest, and it's moving much, much faster. That difference in wind speed and direction across the different layers of the sky is the invisible engine. That's what initiates the spinning you absolutely need for a tornado. So what does that wind shear actually do? It creates an invisible horizontal spinning tube of air. Think of it kind of like a giant invisible rolling pin spinning sideways across the sky. Now, normally this rotating tube just stays horizontal and doesn't hurt anybody. But when you introduce that massive 50,000-foot thunderstorm we just talked about, everything changes. The storm's incredibly powerful updraft basically grabs hold of this spinning air and forcefully tilts one end of that rolling pin completely vertical. And just like that, you have a rotating column developing deep inside the storm itself. And the moment this storm begins rotating vertically, it undergoes a massive transformation. It's not just an ordinary thunderstorm anymore, it becomes a supercell. Now, only a very, very small percentage of thunderstorms ever evolve into supercells, but they are the rare, highly dangerous parent storms that are responsible for producing the vast majority of the strongest, most violent tornadoes on our planet. Once that supercell gets going, the rotating air inside grows unbelievably strong. The storm's persistent updraft basically acts like a giant vacuum cleaner, pulling in more and more warm, moist air from the surrounding environment. And as this happens, the rotating core tightens up and becomes what meteorologists call a mesocyclone. This is the heart of the beast, churning way high up above the ground, just aggressively gathering the energy it needs for the next devastating phase. To really picture how this mesocyclone gains its destructive speed, think about an Olympic ice skater. You know when a figure skater is spinning on the ice with their arms stretched way out, they rotate at a certain speed. But the absolute second they pull their arms in tight against their body, their spin accelerates dramatically. The exact same physics applies to this rotating air. As the supercell's circulation tightens, its speed increases exponentially. At this stage, weather radar can actually see this strong, tight rotation high up in the storm, even though nothing has reached the ground yet. The tornado is taking shape, but it's still completely hidden in the clouds. Now, as that immense spinning gets more and more intense, something fascinating happens to the atmospheric pressure inside that column. It drops, and it drops fast. This localized low pressure causes the air inside the spinning vortex to cool down super quickly. And when that air cools, the water vapor condenses into millions of tiny droplets. That right there is what finally creates that terrifying, highly visible funnel cloud dropping down from the sky. But there's a really vital distinction here that actually catches a lot of people off guard. A lot of folks think the visible funnel itself is the tornado. But remember, a visible funnel is not officially a tornado until that violent circulation actually connects with the surface of the Earth. Sometimes a funnel cloud drops down but never actually touches the ground at all. And honestly, what's even more terrifying is that sometimes the invisible, damaging, rotating winds will hit the surface before the condensation funnel even appears to anyone watching. That's exactly why tornadoes can sometimes start causing major destruction before people even realize they're coming. The true danger begins upon touchdown. The strongest winds typically occur right near the center of the vortex. As the tornado sweeps across the Earth, it acts like a buzzsaw. Dirt, debris, trees, vehicles, and yes, even entire buildings can get completely trapped inside its violent circulation. And the speeds we are talking about are just staggering. While a weak tornado might put out winds around 70 miles per hour, the strongest, most violent vortices can unleash wind speeds exceeding an unbelievable 300 miles per hour. That is a force of nature that can literally wipe a concrete foundation completely clean. A tornado's path on the ground is notoriously unpredictable. Some of them only survive for a few brief minutes, while others can literally carve a continuous path of destruction for well over 100 miles. But they can't survive forever. Eventually, rain-cooled air from the thunderstorm wraps all the way around the vortex, and this effectively chokes off the tornado's supply of warm, moist energy. Starved of its fuel, the rotating circulation shrinks. That massive, wide funnel narrows into what meteorologists call a rope stage, where it gets really thin, twisted, and snake-like. Finally, the circulation just collapses and disappears completely. Though it's definitely worth noting that very same parent supercell storm could always cycle back up and drop another tornado later on in its path. Every single tornado begins with completely invisible, silent changes in the atmosphere. Warm air, cold air, wind shear, powerful updrafts, and rotation, they all have to combine in this perfect, incredibly delicate balance to create one of nature's most violent phenomena. While scientists today understand so much more about the exact atmospheric recipe required to form these monsters, predicting the precise place and time where they'll actually strike remains incredibly challenging. It just goes to show how quickly an ordinary dark sky can turn deadly. So I'll leave you with this thought. The next time you feel the wind shift, and you see those dark cumulonimbus clouds building high above your neighborhood, you really have to wonder, is that just a regular afternoon storm? Or are the perfect atmospheric ingredients aligning right above you right now to create one of Earth's most destructive forces?